For decades, quantum computing has been stuck in the future, always promising to change the world, never actually doing it. But on May 6, 2026, something happened. A quantum computer solved a real materials science problem in 2 minutes. The best classical supercomputer? Over 100 hours. 4 full days of compute time. For fusion researchers running hundreds of these simulations, that's 4 months compressed into an afternoon. And for the first time, experts started asking a dangerous question. What if quantum computing is finally useful? A company called Q-CTRL partnered with IBM to tackle a real problem in materials science. Specifically, simulating electron interactions inside advanced materials. That may sound niche, but this type of simulation sits at the center of some of the hardest engineering problems humanity is trying to solve right now. Fusion energy, advanced batteries, high-performance manufacturing. And here's where things get interesting. The benchmark wasn't against weak software or consumer hardware. The comparison was against methods from the Flatiron Institute, one of the leading classical approaches researchers actually use. The quantum version used 120 qubits and finished in 2 minutes. The classical simulation? Over 100 hours. That alone would have made headlines. But the real breakthrough was accuracy. The quantum system matched industry standard expectations. Not theoretical, not approximate enough to look good in a demo, actually useful. One quantum analyst described the result as signal, not noise. And inside the industry, that phrase matters. Now you might be thinking, quantum computing has promised a lot before. For years, the industry had a credibility problem. Billions invested, headlines promising revolution, governments pouring money into research. But every time a breakthrough was announced, the same thing happened. Scientists would look closer and realize the quantum computer had only beaten classical systems at highly specific tasks designed to favor quantum hardware. The demos were impressive, but they didn't matter. May 6th feels different, because quantum computing has spent years producing noise. Now suddenly, there's signal. And that's when things got interesting. Q-CTRL's CEO went even further. He called this the beginning of positive ROI from quantum computers. Positive ROI, because the conversation around quantum computing has always been about future potential. Someday, eventually, maybe decades from now. But positive ROI changes the timeline completely. The computational problem they solved, simulating how electrons behave in materials, is exactly what's needed for fusion reactors, next-generation batteries, and advanced superconductors. And here's the key. Approximately 1/3 of all global supercomputer time is currently spent on chemistry and materials simulation. That's the bottleneck quantum just cracked open. Now, here's why this matters beyond quantum computing itself. Fusion energy has a massive hidden problem that most people never hear about. The materials needed to build commercially viable fusion reactors don't fully exist yet. MIT researchers have openly acknowledged this. Fusion environments are unbelievably extreme. The inner walls of a reactor must survive crushing magnetic fields, intense neutron radiation, and temperatures hotter than the core of the sun. Scientists have to simulate enormous numbers of material combinations, searching for structures that can survive those conditions. And every simulation takes time. Sometimes days, sometimes longer. So when a simulation suddenly drops from 4 days to 2 minutes, the implication is enormous. It means researchers can test dramatically more possibilities. Discovery itself accelerates. And this is happening at the exact same moment the rest of the quantum industry is heating up. Cleveland Clinic recently simulated a 12,000 atom protein on quantum hardware, the largest biological quantum simulation yet. Multiple quantum companies went public this year. Investors are pouring money back into the sector. For the first time in years, quantum computing feels less like a science project and more like an emerging industry. But here's what makes this different from every other quantum announcement. Now, to be clear, this does not mean quantum computers replace classical computers tomorrow. Most quantum hardware is still fragile, expensive, and extremely limited. But here's what actually changes. Before May 6th, design a material, run a 4-day simulation, adjust your design, Run another 4-day simulation. Repeat for months. After May 6th, 2-minute simulations. You can test hundreds of material combinations in the time it used to take to test one. This doesn't solve fusion overnight, but it removes one of the biggest bottlenecks: the time it takes to discover the materials we need. History rarely changes all at once. Usually there's a moment where a technology stops feeling theoretical and starts becoming economically useful. For AI, that moment was probably ChatGPT. For the internet, maybe the web browser. And for quantum computing, May 6th, 2026 might be that moment. The race just got real. I'm tracking every breakthrough as it happens. Subscribe so you don't miss what comes next.